So here we have a basic template of an APSYS input file has been generated during the export procedure. There are various statements which can be explained just as before by selecting a line and going visualizing on the right hand side. And we're going to comment out a few things which are not used during a purely microelectronic simulation. So this one is for optoelectronic devices, and they also comment out the material 3D.sol, which is redundant because there's a recursive include in the contact 3D.sol file. The last part of the simulation is it controls the actual bias, electrical bias that's applied to the device. So this section is always edited by the user, but we're going to show a template wizard which can help you specify the various scan statements to do various simulations. So in this simulation, we're going to do a threshold voltage analysis. So we're going to use the button here, which since we're working from a C Supreme file, and we need to tell the program again which template we're working from, and we just verify the gate and drain contact electrode numbers. And we're going to apply a small bias voltage to the drain and to the gate. And here we have a slider which allows us to control the accuracy and convergence criterion of the sparse Newton solver. So there's always a trade-off between the accuracy of the solution and the convergence speed. So now we go and we can see that there's been a new file added to our project. So we can examine it, and this is a new template that's been generated from our initial template and with different scan statements which correspond to our threshold analysis. So we can verify this, and we can also see there are a few commands that have been added again, so we have to comment them out once more. And we change the output file name so we can use a different name for every analysis that we want to make. And we can now start the simulation just like in C Supreme. So just like in Supreme, we have our log file and we terminate the simulation. We see in the output files there are several numbers. This is automatic numbering system added to the output files. The first data set is always the initial thermal equilibrium, and then every electrical scan will generate additional numbers. So the first one gives you a drain bias, and the second one gives you the gate bias. So we also just right click and go to Crosslight view. So after Crosslight view has finished loading, we again see our initial structure. Here we want to do threshold analysis, so we use the VT extract button, and we can specify our electrode numbers. And automatically it will plot the required curves and do the analysis. So here in blue we have the IDVD curve, and in purple there's the automatically computed transconductance. So to compute the threshold voltage, we take the slope of the IDVD curve at maximum transconductance, and then we calculate the intercept, and that gives us our threshold voltage. Now we want to simulate the IDVD family of curves. So we're going to go back to our SimuApsys and we're going to generate a new template based on the IDVD wizard. So the rules are basically the same as before. We take our existing empty template and we're going to generate a set of gate biases at 1, 2, 3, and 4 volts for a specific bias drain. And now we rerun the simulation like before. We can also modify the file a little bit to comment out the files and rename the output that we don't need. So now we're nearing the end of the simulation. Overall, we're going to have 9 output files in total. The first one is going to be the equilibrium. Then for each of our 4 family of curves, we have 2 files. The first one is going to scan the gate voltage, and the second one is going to scan the drain voltage. So for IDVD value of curves, we're going to use files 3, 5, 7, and 9. So as before, we go to our output files and we're going to pick one to open in Crosslight view. So to view our IDVD curves, we want to plot scan bias data. So we pick, we change the electrode to number 3 for the drain, and we're going to pick data sets 3, 5, 7, and 9. And we're going to plot voltage versus current. So these are our IDVD curves. So here, just to make things clearer, we're going to relabel our scans. You see, instead of a data set, it's using scan number, which is an alternate numbering system. But this corresponds to our various gate voltage of 1, 2, 3, and 4 volts. So in addition to our scan bias data, we can plot structural data and just plot the internal distribution of different variables. So here we're going to plot the potential distribution, and we can also scan, move, and do contour plots just like before. This pretty much concludes our Nova TCAD tutorial. If you have any other questions, please visit www.crosslight.com.